Okay, so I hope you can see the screen.
Yes, sir.
So yeah, so today we'll be talking about condition variables, and so last time we saw something about like uh, how threads use locks to synchronize things, and today we'll talk about the case when one thread needs to communicate with the other. Okay, and it does so because it wants some condition to be true or false before it continues its execution. Okay, so question is what to do when a thread wants to check for some condition to be true before continuing execution. More specifically, we would want this condition or the one like this condition about some other thread. Whether the other thread has completed its job, or some operation that it needed to do it has done. Okay. So this is the idea that this is the problem that we want to solve. That we want some communication between the threads. That okay, one thread has done something, and then the other thread should know that okay, that job is complete. Now I can start executing. Okay. So the first approach is the simplest one. Is going to be have a shared variable and the parent thread spins while the variable is not changed. Okay, so this is a very simple approach. So if you want to look at the code of this, so not this one. So you just have one variable here. This is the shared variable, and so now the child basically just changes the variable here. What does the parent do? Parent prints parent begin. It creates the child, and when it just here it spins if variable is not changed. So this way it will continue only after the variable has been changed by the child process. So once the child process makes the variable to be 1, then it can come out of this while loop, and then it prints that parent end, and it can return. So what is the problem with this approach? The basic problem is just inefficient. You don't want to keep spinning while the child is doing something. You might want to go to sleep or do some other work and so on. So that's where the term condition variable comes in. So what is a condition variable? It is an explicit cue that a thread puts itself on while waiting for some condition. Some state of execution, some condition. Okay. And now what happens is that when some other thread, so when the state of execution is not as desired, let's say. So now if some other thread changes it, changes the state or the condition, okay. So the thread which was waiting, it wakes it up. Right? Why? So signaling. Okay. So the two important terms are waiting and signaling. Okay. So basically, so let's see how we first declare a condition variable, and then we see a basic example of how it works. So declaration is going to be pthread condition t, and then c. C is the condition variable here. Okay. And you need to initiate also. And then associated with every condition variable, there are two routines. As I said, wait, and the other one is signal. So what does wait do? The thread puts itself to sleep. And what is signal? So this does it after checking some condition. And what does signal do? When the thread has changed the condition, something, and wants to wake up some other thread. Yeah. So that's when we'll use signal, and we'll use wait when the thread wants to sleep. So what is the syntax for these two? So p thread wait. This is the routine. And what does it take? It takes a condition variable and a lock. Okay. We'll see why these things are important and what it should take input as and so on. And what about the signal call? It just takes the condition. So this is the syntax of these two calls, and we'll abbreviate them as wait and signal as we were doing earlier while talking about them. Okay. So what does wait do in slightly more detail? So it takes a lock and condition variable as parameter. Okay. And assumes that, okay, so instead of lock, let's call it mutex because otherwise the lock word will get repeated many times. And assumes that the mutex is logged. Okay. When wait is called. So it's the responsibility of the calling thread to log the mutex before calling wait. Okay. And then what does wait do? Wait releases the log and puts the calling thread to sleep. And it does all this atomically. So in one step, I mean, not one step together, it releases the log and also puts the thread to sleep. And when the thread wakes up, it reacquires the lock before returning to the calling thread. So that's the semantics of wait. And signal is relatively easier. Signal just wakes up one of the threads waiting on the condition. Which condition? The condition which is the parameter for signal. Okay. So it will wake up one of the threads which is waiting for that condition. Okay. Waiting on that condition. So let's see an example of this in work. Okay. Is it readable?
Yes.
Yes, sir.
Okay, good. So yeah, so here this is the shared variable which we want to change by the child. Okay. And then we uh, declare and initialize the lock. Sorry. Yeah. And the condition variable. Okay. And now we want the parent to. So let's. So parent starts. It prints this. Then it creates the thread. So now there can be two things, that the new thread can start running or the parent can start running. So let's see so basically what we want is that the parent to wait for the child to finish, and then it should print parent end. Okay. So that is the basic idea that we want. So now there can be two conditions, that the parent immediately runs after creating the child or the child starts running. So let's look at the case when the parent runs after creating the thread. Okay. So now it calls the routine thread join. Okay. And what does thread join do? It first acquires a lock, then it checks whether the variable has been changed. So the variable was initialized with 0. Okay. The done variable was initialized with 0. So if it is still 0, then the and it is still 0 because the child has not started running. So it goes to sleep. And as the semantics of wait says, after releasing the lock. And then it calls the thread exit routine. So let's come to thread exit routine. So what does it do? It acquires the lock. Then it changes the variable. And then it signals the parent thread, which has been waiting on this variable. Okay. On the C variable. So that wakes the parent up, but still the child is running, let's say, and then the child releases the lock. Now, when the parent gets scheduled, it acquires the lock before returning, and then it releases the lock. Now it comes back here and then prints the message and then returns. So this is the flow that happens here. So if I went too fast, or if there is any question about this, please ask. So what we want is the parent to print first parent begin, then we want the child to print child, and then we want the parent to print parent end. Okay. And we are using a lock and a condition variable, and uh, also one like shared variable to indicate the that the job has been done by the child, what was required. Okay. So I'll give you a moment to just go through the control flow once. And if there is any question, please ask. Okay, no question. All right. So if there is no question, then let's now see that why these things are important, like why we need to have a shared variable, why the lock is there, and stuff like that. Okay. So let's first look at a program which does not have a lock, or it does not have a variable. I don't know which one is first. Okay. So suppose there is no variable. So here we had this variable, the shared variable, to be 0, the shared variable done. And suppose now we have a program which does not have any such thing. So now thread exit, what does it do? It just has the lock. It just signals and releases the lock. Well, what does the join do? Join acquires the lock and waits on the condition and then unlocks the mutants. So here, okay, so let's see what can go wrong. So suppose the parent, okay, we didn't, okay, nobody's asking questions. I don't know why. We didn't worry about the second case here. The child runs first. I mean, starts running right after being called. Okay, so let's do it by another color. So I had not finished that part. So what happens in that case when the child runs first? So when the child runs first, so parent creates the child thread and then the child starts running. Okay. So now the child comes here, it prints. Okay. It comes here, then it calls the thread exit routine, which takes it to the thread exit. It acquires the lock, changes the condition variable, and signals not the parent thread, but I mean whatever thread is waiting on the this condition variable. But there is no thread right now waiting on the condition variable, so it just returns and it releases the lock, and the child is done. Now the parent comes and parent start executing the join routine. Now it sees that okay, the variable done is not 0, it is 1, so it does not go to sleep, and it just comes out and unlocks, and then comes out of the thread join routine. Then it prints the message it is supposed to print, and then it's done. Okay, so in both the cases, the control flow is, or I mean, the way the processes are running is the way we desired that. Okay, the first the parent prints begin, then the child prints while the parent is waiting, or if the child runs first, then it's fine, and then the parent prints, parent end. Okay. Any questions? Please ask questions. Otherwise, I will not understand whether you are getting it or not. Okay. So, all right. So I was discussing the case when there is no state variable. Suppose we don't have this. Done. Let me try to get this. Okay, now it's too small. All right. So here we had the thread exit. So here we don't have just, we remove this line. Done. Okay. We remove this line. Done is equal to 1. Okay. And also from the this thread join, we remove this line. So what are the routines that we get? We get these routines. Thread exit, just It basically just signals, and join just waits. So now the parent suppose starts first, it calls thread join, it acquires the lock, it is waiting on the condition C, good, and then it goes to sleep. Now the child starts, child calls the routine after it has done its job, it calls the routine exit. Now it acquires the lock, it signals, signal wakes the parent up, parent then acquires the lock after waking up, then releases the lock, then returns to the calling thread after this join operation is finished, and then finishes. So that is fine. So what goes wrong? What can go wrong in this case? So if parent runs first, then we are good. But what happens when the child runs first? Anyone? Now I've told like what is the problem, but what happens if that happens? I mean, what happens when the child runs first? Somebody has to answer. I'm not going to go ahead like this. Now the child is running first. Then what happens? It acquires the lock, it signals, but there is nobody waiting for it. So fine, it just exits. What happens to the parent?
Okay, then the wait will never return.
Yeah. So the parent starts here. It acquires the lock. It calls the function wait. The wait releases the lock and goes to sleep. But now, who will wake him up? The signal has already been sent, and the signal is gone from the child. And the parent goes to sleep. There is nobody to wake him up. The parent will keep sleeping forever. Okay. So that is the problem with this. So that is why it is always, you should check on the variable before calling wait. Now let's see another part where suppose we don't use any locks. So here we just change the variable in the child thread, and the parent thread just checks whether the child thread has updated, and if it has not updated yet, then it just goes to sleep and just waits for the signal. So what can go wrong here?
After the parent thread checks for equal to 0, after that the child thread may get scheduled and like complete, and then the wait will never return.
Exactly. So suppose the parent has now checked that condition, checked the if, and has decided to call wait. That is to go to sleep. It has decided, but it has not yet executed this instruction. Okay, it has not yet gone to sleep. And then the child gets scheduled, an interrupt happens at that particular point, and then the child gets scheduled. The child changes the variable, it signals, but there's nobody to hear that signal right now because the parent is not yet sleeping. And then the child signals, exits, and then the parent executes the statement and it goes to sleep and then again never wakes up because the child has already finished its execution. So there will be nobody to signal it. There will be nobody to wake. Okay, so that is the problem if we don't use locks. So you see that both the lock and the variable are important parts of the code. Okay? Good. So now let's come to slightly. So now we have seen how to use these, how to declare a condition variable and how to use it to wait and signal. Now let's make use of it to solve a slightly more complex problem called the producer consumer problem. Okay. It is also called the bounded buffer problem. Okay. And suppose there is one or more producer threads and there is one or more consumer threads. And what do they do? What do the producers do? They produce. So what does the producer do? Generate some data item. Okay. And put them on buffer. What does the consumer do? They consume the item from the buffer. That is, they remove it and use it in some way. For example, you can just have a queue of requests, which are so producer just takes the requests, like of some kind, whatever. Suppose you are running, some website or something, and some requests are coming, and the producer is one thread that keeps taking those requests and keeps putting them on the buffer, and then the consumers are the ones who are responsible for taking care of these requests. So when they like when they see those requests, they take care of it and remove them from the buffer. So that is the idea. This is what we want to achieve. Okay. So buffer is the shared memory, and that's why it needs some synchronization. Okay. So basically, let's see what we want to achieve here, sort of. So we have these. So suppose we just use first. Let's say we just use an integer for the buffer, and then we'll make it more complex later. So let's say just one variable integer for buffer. And what do we want? We want it to be, so count will denote whether empty or not. Okay. And so what does put do? So the producer thread will use this put routine. And what will it do? It will check whether it is empty. If the buffer is empty. So it will only work if the buffer is empty. Then it sets the count to 1 and put some value in the buffer. So it takes an argument as a value and it puts the same value in the buffer. So now the buffer holds that value. And what does the get routine does? So this is the put routine. And now the get routine. So what does the get routine do? Get routine first sees if the buffer is full. And if it is, then it sets the count to 0, make the buffer empty. And returns the variable. So it returns the variable and sets the count to 0. So, or like sets the count to 0 and returns the variable. It does not matter. So it consumes this value, the current value of the buffer, and sets the count to 0. Okay. So this is what we want to perform on the buffer, but now we need some synchronization and so on. Okay. So as we said, there are two threads, the consumer and the producer. So let's see what we want them to do, sort of. So very naively, if we don't want any, if we have not implemented any synchronization tools. So what we would want is for the producer to, let's say, some loops number of times, which is the argument to the producer. We want to put like the number I, where I is the loop count on the buffer. Okay. And for the consumer, basically we would want it to keep removing things from the buffer. So it is an infinite loop. So again, this is a very the first starting code for the producer and consumer. And so this is not, but this should give you an idea that what we would try to do with or what the producer and consumer are trying to do. So what the consumer does, so the producer puts the value I on the buffer and the put code is above. The put code is this one, that it puts the count to 1 and then changes the buffer value to the whatever the current value of I is. And then what does the consumer do? The consumer prints the value and then keeps removing that value from the buffer, makes the buffer empty, and prints the current value of the buffer. So this is the consumer, yeah, and this is the producer. Okay, so of course, this is not going to work because this is the same variable that both are accessing, the buffer variable. So we need to put a lock around, especially a lock around the put routine. So needs a lock around put, and this would need a lock around get. But just the lock would not do, as we saw last time, because then again the whole problem will happen that okay, how will the consumer know that the producer has put something there, and how will the producer know that the consumer has put something there? So we need to use both locks and condition variables for this to solve this problem. Okay. So let's now see one solution, which let me just Okay, so let's see the first try when we use a condition variable and a lock to do this. So now we have some int loops, which is like, it should be initialized. So we are going to do this loops number of times, the whole process. And we have the condition variable. We declare it here and have we not initialized it? So suppose we also initialize it. So this also needs to be initialized. The mutex also needs to be initialized. So this is the lock that we declare. And this also needs to be initialized somewhere. But okay, so that is not the interesting part. Let's look at the interesting part. So now what we want to do, so this part remains the same, that we run the, so line 7 like basically is the start of the loop. And now we put the lock around the put statement. But before putting, we check the condition. We check here if buffer is full, then go to sleep, waiting for the consumer to signal. Okay, this is what it wants to do. So it goes to sleep, then it wakes up when the consumer basically tells it that, okay, now I have put. So it wakes up and then puts I on the in the buffer, and then it signals the consumer that, okay, I have put something on the buffer, and then the consumer wakes up and then it releases the lock and continues with the loop. So similarly, what does the consumer do? The consumer acquires the lock, again checks if buffer is empty. If so, it goes to sleep, waiting for the producer to signal. Okay, and then it just so it stores the value in temp after that. So now when the producer signals in line 22, the consumer will wake up. It will acquire the lock, then it will store the value. So it will call the get routine. It will store the routine of the return value of the get routine into temp. It will print temp, and then it will signal the producer that, okay, I have consumed. Buffer is empty, and then release the lock. Okay. So this is the routine that the producer and consumer are doing. So yeah, there are two problems with this code. This code generally works fine if there is just one producer and one consumer. But if there are like more than one producers, more than one consumer, then this breaks down. So can someone guess what can be at least like, one problem that can happen?
So the condition that it checks, so on line like 21 it says if count is equal to 0 and then it waits.
Yeah.
So if it is then woke up by another consumer thread, then the count would still be 0, but it would exit and just try to get something. when
Exactly.
nothing is.
Yeah. So yeah, the Arpit got it right, but let's just go through it in detail. What he said. So suppose now there are two consumer threads, and there is only one producer thread. Okay. So what does the producer do? Okay. So the producer goes. So it starts. It sees that okay. So suppose initialized there is nothing in the buffer. So the count is 0. So now the producer starts. It starts. So producer starts. It goes to line 8. Let's say it acquires the mutex. Line 9. Now it checks if the count is 1. The count is not 1, so it does not go to sleep. It puts something on the buffer. Okay. And now, no wait. So should the parent run first? No, parent should not. Yeah. So suppose one of the consumer runs first. Sorry. So the consumer runs first and then it goes and it sees that the count is 0. So it goes to sleep. So consumer 1 goes to sleep. Okay, good. Now what happens is that the parent runs and parent comes here. It again checks if the buffer is full. The buffer is not full, so it puts something on it, and then it signals. Okay, for this guy to wake up. Now this guy has gone to sleep. He wakes up. C1 wakes up here, but it is not yet scheduled. So the parent releases the lock, and the parent, not parent. I keep the producer releases the lock, and the producer is done. Now suppose what happens is that there is another consumer that gets scheduled before this guy who was sleeping gets scheduled. Okay, so now this guy is not asleep though. It has woken up. But what happens is now C2 gets scheduled before C1. So what will it do? It will come here. It will see that the buffer is not empty. So it will not go into sleep. It will use the get, empty the buffer, print the value, and then get done. So that is how the C2 will finish its whole process. And then now suppose C1 gets scheduled. So now C1 when it gets scheduled, it has woken up, so it will try to get something. It will try to execute this line 23, but there is nothing to get because whatever was there, it has already been consumed by the thread C2. So that is what is done in this control flow that, okay, first the C1 runs, it goes to till C3 and it goes to sleep. Then the producer runs, and once it produces something, so it produces something, then again for the next loop it goes, and now the buffer is full, so it goes to sleep. So here the producer goes to sleep. And now, as I said, this thread does not get scheduled. Some other consumer thread gets scheduled, and it finishes the whole loop. And then after that, the first thread will get scheduled, and it will start from this line, the get line. Okay. And now there is nothing to get in the buffer. So that is why this is wrong. Okay. And actually the fix for this is actually quite simple. Use while instead of if. So the code basically looks like, okay, let me remove this for now. Then I'll try to put that. Can we see both of these? Okay, yeah, maybe. So, okay, so now we have put the while instead of loop. So here we have changed this line. Here there was an if condition in the previous program. We have just changed it to a while condition. Okay. So why will this solve the problem?
Because when it will try to, like when the consumer thread will try to get, it would always be sure that count is not 0.
Yeah, that the count is 1. So it keeps rechecking. It's not that it has woken up and then it will keep to come out of the while loop. It will have to make sure that the count is non-zero. So now the same thing would happen. So suppose the consumer thread 1 comes here, goes to sleep. Let me not draw too many things here because I'll bring that thing. So it goes to sleep in line 22. Then the parent does it it puts something in the buffer and then goes to sleep waiting for it to be consumed. Then some other thread gets scheduled, the consumer thread gets scheduled, then the consumer thread consumes the item which was created by the parent. Now this, the first consumer thread comes here, it gets scheduled, it is still in the while loop. So it returns, but it still checks the condition whether the while condition is true or not. And since it is still true that the count is 0, it will not come out of the while loop and will go to sleep again. So that is why whenever you are checking on the condition, always you use while, because if causes these problems that once it is not true, then you just come out of the if statement, but while you have to keep rechecking. So basically what happened here was that the thread was waiting and then some other thread changed the condition, and so the thread woke up basically. So the producer woke up the consumer thread. Now the consumer thread is awake. So this just told that, okay, the state has changed, but it does not know if the state will change before it gets scheduled. So there are like 3 points of execution. One is so here suppose the parent, or again, I keep using parent, I don't know why. Because producer wakes, let's say consumer 1, and now the consumer 1 is awake. So consumer 1 thinks that buffer is full, but it can't take this on the face value that when it will get scheduled by that time, still the buffer will be full. It needs to check again, because what can happen if it does not check, then like maybe there was some other C2 consumes buffer and then C1 gets scheduled. So it was woken up, but it was not scheduled. Now it gets scheduled. And now if it does not check the condition again, then it is in trouble, because it is still believing the information which was sent to it, some time ago by the producer. So that is why this information should be taken as a hint and not should be taken completely at face value. Okay. Good. So what is the other problem that can happen here? Can there be some other problem that somebody can think of?
So, is there an efficiency problem? Because the signal goes to, like, a consumer signal goes to other consumers as well. Ideally, it should go to only producers.
That's actually true, but it's actually not a. I mean, this is true that it does go to the signal. Actually, so another fine point, maybe I didn't emphasize it enough, is that signal wakes up only one thread. Okay. So signal does not wake up all the threads. So there is another routine to wake up all the threads. It's called broadcast. So you go pthread T condition broadcast. That will wake up all the threads which are waiting on that condition variable. But signal just wakes up one thread. So yeah.
Okay. So if the consumer thread signals and another consumer thread wakes up, then
Yeah.
that consumer thread will go waiting, and then no thread will be able to run.
Exactly. So, like, did everyone get what Arpit was trying to say? Or can somebody else, at least, after he has said, try to get it? That okay? Okay, so the problem here is that we are using just one condition. Same condition to wait and signal for both producer and consumer. Again, if there is only one producer and one consumer, this is fine. But if there are more consumers, more producers, then this becomes problematic. And why this becomes problematic is for this reason that a consumer can wake another consumer up. And why, or if you want to see that in little bit more detail, then let's see. Okay. So, all right. So, somewhere. So the line numbers are. Okay, maybe this is still kind of visible. Hopefully, yes. Okay, good. So, what happens? Suppose that first, so there are two consumer threads, TC1 and TC2, and one producer. So these two are consumers. And this is the producer. So we are going to look at the trace. So what happens is first, suppose the first consumer thread gets scheduled. So it goes through lines C1, C2, C3, and then it goes to sleep because there is nothing to get because the buffer is currently empty. So the consumer thread goes to sleep. Then suppose the other consumer thread wakes up and then it also not wakes up, like it gets scheduled. It also performs the same routine. It goes C1, C2, C3. It again goes to sleep. So both are asleep at this point. So here, both consumers are asleep. Now the producer starts running. The producer runs through P1, P2, P3. It of course does not go to P3. It checks if the count is equal to 1. The count is not 1, so it goes to P4. It puts something, then it signals, then it unlocks, then it goes through the loop again. Then it acquires the lock. It now it sees that the buffer is full, so it goes to sleep. So here the parent goes to sleep, and the buffer is full. Again, the producer goes to sleep. Okay, it is saying that I'm working offline, but it is still updating. So okay, so the producer goes to sleep here. Now what happens? Now it has signaled. So here in this line, when it does P5. So here it does P5 and then it wakes up TC1, suppose. So this thread wakes up. Now this thread wakes up and then it starts here at C4. Or, I mean, it first checks the while loop and then it sees that the count is not 0. So it comes out. It performs the get routine. So it goes to C2, then C4. Then it signals. Okay. Now this signal is on the same condition variable that is used by here by the consumer itself. So if there is another consumer, it wakes, suppose the other consumer, it wakes TC2 up. So here in this C5 line, it woke up TC2. Now TC2 is awake. Now it finishes its business. It releases the lock. It writes the, it prints the output. Then it goes through it again, and now it sees that the buffer is full, so it goes to sleep. So sleeps. Now the parent is the producer is asleep. This guy is asleep, and now who is awake? TC2 is awake. So TC2 gets scheduled, and then TC2 checks for this while condition, and it sees that the buffer is empty, so it also goes to sleep. So basically, at the end, all three threads are asleep. Okay, so this is the problem with this approach. So what can be the solution? What is the simple solution for this?
Just wake all threads. One solution could be that.
Sorry.
One solution could be that, like instead of signal, use broadcast.
No, but still the problem can happen. So broadcast will wake everybody up, but then who will get scheduled? You have no control over that.
But if the consumer gets scheduled late and then go to sleep again, then the producer will get scheduled.
I mean, yeah, at some point, true.
Yeah, it will work. It's not very efficient.
Yeah, that's true. So, but another solution, anyone? So another solution is just use different variables for consumer and producer to wake them up. And that solves it. So the solution for this is like, use two variables here. Okay, so here we have these two variables, empty and fill. Okay, so what is empty? Empty is what the parent waits on, the producer waits on, that when it's empty, then it will wait. And fill is what the consumer waits on. Okay, and the producer will signal fill that it has put something onto the buffer to the consumer, and the consumer will signal on the empty. So here you see that again it's the same code, except that now the producer uses empty here to wait, and the consumer uses empty to signal. So you see that this is one variable, and now the producer uses fill to signal, and the consumer uses fill to wait. And now there is no problem. So now what happens when anything is so when a consumer basically tries to wake up, it will only do it through the empty signal, and who is waiting on the empty signal? No consumer is waiting on the empty signal, empty condition variable. Only the producer is waiting on the empty condition variable. Right? Similarly, when the producer signals on the fill condition variable, no producer is waiting on. So the producer waits on empty condition variable. So no producer is waiting on the fill condition variable. Only the consumers are waiting on the fill condition variable, and they will get woken up. So whenever producer puts something in the buffer, one of the consumers will be woken up. And whenever the consumer empties the buffer, one of the producers will be. So this is the actual routine which works. Okay, so now you can just modify it a bit more too. So here our buffer was just one variable, but you can make the buffer to be an array, for example. So here the buffer is array. Then you have a fill pointer which will be used by the producer. And you have use pointer which will be used by consumer. And then you have count to indicate how many entries are there. Okay. So this is how you and what does the put do? Puts the at the current used by the producer, points to the current empty index. I mean, current empty index is till the buffer is full, and then after that it's empty, it will point to that index. So it will put the value at that particular index. So suppose you have an array. Currently the fill pointer is here. So it will put the value here. And then it will increase the pointer. So then the fill pointer will point to the next. And then it will increase the count also. So suppose the count was 10 before, so now the count will become 11. What does get do? Now get will use the use pointer. Use pointer will point to the last value in the array. So till where the array is full. So suppose the array is full till here. And after that, this is not yet filled. So then the use pointer will be pointing here. And what will the get do? Get will just store this value. Oops. Get will store this value in temp. And then return that value. And then decrease the pointer. Okay. Sorry. So use pointer is use pointer plus 1. Okay. So and then it will decrease the count. So it will put the variable in temp, and then it will decrease the count, and it basically consumes this entry. Okay, and this is for basically circling through the count. Okay, so after the producer produces, after this, when it reaches here, then it the count will become max, and then the use pointer will come to 0, and similarly for use pointer. And now we just update our producer and consumer codes also just to reflect this, that if count is equal to max, then we put I, and if count is equal to while count is equal to 0, then we wait, and here if count is equal to max, then we wait. Otherwise, the code remains exactly the same. So this is what, like, so this has been like a very important problem, the producer consumer problem, and so there are some, like, nice ways to deal with it. One of them is condition variables, and next time we'll be learning in the next lecture one more way to deal with such things. It's semaphores. And yeah, so that finishes today's thing. So basically what we saw today is that whenever these threads want to communicate, there need to be some signaling mechanism between them so that they can communicate, and that signaling mechanism is built upon these things called condition variables, and they use to do it. And the main thing was the wait and signal calls. And I hope the semantics and how they work is clear after these examples. So any questions, anything? Okay, cool then. So anything about the assignment or whatever, like in general, any query? We have like 1 minute. No? Okay then. Thank you everyone for coming, and let's meet on Thursday.